Hey guys, we've made it all the way to day 9. This is our last day of new content. So keep that in mind because we know our test is on Thursday, 2 days from now. And so this is going to be part 1 of day 9 that gets posted. Of course, part 2 will go along with it. But the big thing from this day, one of the big things is going to be the triangle inequality theorem. And then here on part 1, we're going to talk about that, and then we're going to talk about what's called the hinge theorem. Those are going to be the 2 big theorems we'll look at in part 1 today. But let's focus on this first one, guys. We're going to be able to apply the triangle inequality theorem to determine if a triangle can even exist based off its sides and angles. So if you notice, the triangle inequality theorem, it is all about telling if a triangle can exist. And here's what this theorem says. It says that the sum of the lengths of any 2 sides of a triangle, so in other words, adding any 2 sides of a triangle, should make it bigger than the length of any third side. So this is a little tricky here. So that means that any 2 sides have to add up to be bigger than a third. So for example, here's our triangle. A plus B has to be added up to be bigger than C. A plus C has to add up to be bigger than B, and B plus C has to add up to be bigger than A. If this doesn't work, spooky. I thought Halloween had already passed. But I want you guys to think about it this way. If this doesn't work, you can't make it back around to complete one side of a triangle. We would stop short, if not true. If you couldn't go with 2 sides added together and it would get you back to where this side is, then you don't have a full triangle. So if this isn't true, you're going to have a gap in your triangle. And so let's see if this first triangle could happen. So we're going to determine whether these 3 measures, which we assume represent the lengths of the sides of a triangle, will make it to where it would create a triangle. So here's A, here's B, and here's C. Let's see if these all would add together to work. So we know each combination has to be bigger. So we got 9 plus 12. That's going to be 21, which is bigger than 8. Checks out. How about 9 plus 8? That's going to be 17, which is bigger than 12. Checks out. And then how about 12 plus 8? That's going to add up to be 20, which again, this is going to be bigger than 9. So we would say yes. This is a triangle that could exist. So I'm going to let you guys try number 2 and number 3 for me. See if these 2 triangles could possibly exist if they had these 3 sides each. So you can go ahead and pause the video and give it a shot. Okay, so we try this out. And right off the bat on number 2, 8 plus 9 equals 17. But it has to be greater than that third side. So even though these 2 work, that is a no. This triangle could not exist if it had these 3 sides. How about this one over here? Again, immediately, 23 plus 26 is 49, which is actually smaller than 50, not bigger. So even though these other 2 work, this is no. How about let's try a real world problem. I actually was planning on running a half marathon this month. This could have been me, but it got canceled. So, way to bring up bad memories, me. But so Mildred, what a name, by the way, is training for a half marathon. During her training run one Saturday morning, she ran 5 miles in one direction. Okay. So let's say she starts here. She ran 5 miles maybe this way. Then turned and ran 4 miles in another direction. Okay, so then maybe turned and ran this way. And then finally turned and ran back 3 miles toward her starting direction. So the question is going to be, will these 3 dimensions end up getting her back to where she started? So when she stopped, was it possible that she was back at her starting point? So in other words, it's like this up here. We need to check to see if it was possible for her to have made it back. We're assuming she didn't just immediately run 4 miles back in the same direction, because then that would be the same side. You'd only have 2 sides. She had to go another direction. So we'll see. Let's find out. So we've got 5 plus 4. That's 9, which is bigger than 3. We've got 4 plus 3, which is 7, which is bigger than 5. And we've got 5 plus 3, which is 8, which is bigger than 4. So, hey, all three of these worked out. So, in fact, absolutely, you can make it back. This is a yes. She could have made it back by doing that. Absolutely. So, excellent, excellent. So, last thing kind of dealing with this theorem is going to be, we want to be able to find the range that a potential third side could be whenever we've already been given the measurements of two sides. So for example, let's say we've got 6 and 19. These are two sides of a triangle. Well, how can we find out what our third side is going to be? Well, here's how we do it. We take these two sides, and to find the low point, actually, let me rewrite this. We'll go 19. Obviously, you want to do the big one here. We'll add these two together to see what they need to add to be as far as being greater than the third side. Then we're also going to subtract them to see what the low bar is to where the other side would need to add up with 6 to be bigger than 19. So we're going to get the high and the low. The high and the low range. So let's see. 19 plus 6, that gives us 25. 19 minus 6, that gives you 13. And let's call our third side x. So x is our third side. So how is x going to need to compare to 13 and 25? Well, x is going to obviously need to be bigger than 13 because 13 plus 6 would be 19. And if you remember, we need two sides to add to be bigger than the third side. So x needs to be bigger than 13. So 14 plus 6 would be 20. That would work. But x can't be, if x has to be smaller than 25 because 6 plus 19 is 25. So x needs to be smaller than 25. So what could be a number that works? How about, could 14 work? Yes, it could. 14 plus 6 is 20, which is bigger than 19. What about 28? 19 plus 6 is 25. Ooh, that's smaller than 28. That would not work. So this right here would be our range. And so I'm going to let you guys try number 2. And then go ahead and try number 3. We got a nice little multiple choice problem down here. See if you can do number 2 and number 3 for me, please. Let's see what you get. Let's see how you guys did. So 13 and 27 are two sides. So to find the boundary for our third side, x, we know we need to add those. So those add up to be 40, which means our third side needs to be smaller than 40, because obviously these two have to add up to be bigger than 40. But we need this side plus 13 to be bigger than 27. So that plus 13 needs to be bigger than 27. So we need to be bigger than 14, because 14 plus 13 is 27. Now, as far as number 3 is concerned, we've got a triangle, x, y, z. We know x, y is 8. Y to z is what we're trying to find. What measure could it not be? We know x to z is 14. So what could yz not be? Well, 14 plus minus 8, do the same thing we did a second ago. We see that our boundary needs to be, we got to be smaller than 22. But we got to be bigger than 14 minus 8 would be 6. So that is what that side needs to be. So x needs to be bigger than 6, but smaller than 22. Oh, right there. It's got to be bigger than 6. Can't be equal to 6. And so we wanted to know what it cannot be 6. These other 3 would fit in between these two. So guys, let's go to the last page and finish up part 1 of this video. All right. On to the Hinge theorem, which I'm pretty sure Hinge, is that like a dating app or something? I don't think that's what that's going to be about, though. Let's see. If I had a way to sum up this, look how wordy this is. This is so many words. If I had a way to sum this up, it is bigger angles make bigger sides. If I could sum this whole theorem up, I would say bigger angles make bigger sides. So the bigger the angle, the bigger the side. And that's all this is saying here. It's saying, hey, if two sides of a triangle are congruent, and two sides of another triangle, and the angles the other two sides of a triangle are congruent with another two sides. So check this out, 3, 3, 5, 5. But one triangle has a greater measure than the angle of the other, then the third side of the first triangle is longer than the third side of the second. So in other words, that's 90 degrees. That opens up to make this side right here. This triangle, which has the same side, but has a 100-degree angle, it opens up to make a longer side. And so all this theorem is saying, guys, is it's just saying, hey, 100 degrees bigger than 90 degrees. Which means this side, let's call this side B, and we'll call this side A. That means that B is going to be bigger than A. The bigger the angle, the bigger the side. That's all that theorem is saying, guys. So we would say, which car is further from the mall, car A or car B? Well, because this angle opens up and makes a bigger side than this angle, we would say car B is further from the mall. And we justified our answer right here. How about a fun one? One of our worst nightmares is getting stuck in a lake or a pond with an alligator or a crocodile. How about just a quick converse here? What happens if instead of being given an angle, you're giving a side? So check this out. Suppose that the distance between points C and B and this alligator is 27 inches. So this alligator's mouth opens up 27 inches. But this alligator, E to F, is going to open up 30 inches. Which angle is going to have the largest measure? Will it be angle A or will it be angle D? Which angle is going to have the largest measure? Well, because this side is bigger than this side, and these two angles project both these sides, we can safely say, hey, angle D is going to be greater than angle A because 30 inches, the side that this angle creates, is bigger than 27 inches, the side this angle creates. Does that make sense, guys? The bigger the angle, the bigger the side. The bigger the side, the bigger the angle. That's all this converse is saying right here. Okay, so the converse again is this is bigger side makes bigger angle. That's all that's saying there. The bigger side makes the bigger angle. Okay, so I'm going to let you guys do a little exercise here. See how you can do with 1, 2, 1, 2. You are going to write an inequality. So for example, you're going to tell me, hey, is MR bigger or smaller than RP? Well, that's 21 degrees projecting to MR, and that's 19 projecting to RP. So you're going to put the sign, you're either going to put a greater than or a less than sign on 1, 2, and 1, 2. So go ahead and guys, give me your best shot, and we'll be done with part 1 of our video. And go ahead and pause. And you guys can see, just like with this one, I drew arrows, and I like to connect what the actual numbers are to help me too. So 21 degrees was going to MR, 19 degrees was going to RP. You can see MR is greater than RP. AD, Anthony Davis, greater than CD, whoever that is. 38 degrees opening up compared to 22 degrees. That makes sense. Now down here they give us the sides, and we have to see about angles. So if this side's 13 and this side's 10, that means this angle is going to be greater than this angle. And likewise, if this opens up to 11 and this opens up to 16, that means this angle creates a bigger side, so it is a greater angle than this one. All right, thank you guys very much. I'll see you in part 2.